My name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we will be implementing algorithms and data structures using Scala Functional programming approach. All the code related to our videos or whichever we implement will be provided as a link in our description, and those link will be to my GitHub repository. In this video, we are going to implement breadth first search. Breadth first search is a traversal technique used with trees as well as graph. In trees, it is less complex, but in graph, it gets complicated because in graph, we have cycles. So let's take an example of the graph. We had used similar graph in our depth first search. So as we see from A to G, G to H, H to F, F to A. This is a cycle that is present in the graph. And then from A to B, B to C, C to E, C to D, and D to E. This is another cycle. So now when we are traversing this graph, so in our breadth first search, we will go from A to G and B. So this will be the first two neighbors. Then H, and for B we will have C, and then for H, F, and C we have D and E. So this will be the order. So as we see here, A to G, so it will be A to G and B, then H, C, H and C, and then neighbors of H and C, F, D, E. So let's implement this. We will require few helper methods to make this happen. So first helper method is add sequence to sequence. Okay, def add sequence to sequence. This will be of type V. It will have first parameter as sequence 2, which will be of type sequence V. Another parameter will be sequence from, which will be of type sequence V, and it will return a sequence of type V. Now it will be sequence from dot fold left, it will be sequence 2. Now here it will be sequence comma value. Now for these two we will implement a method if sequence contains value, then it will be sequence, else sequence, else sorry, there should be a gap, else the value will be appended to a sequence. So now this is how it will be. This is our first method that we are going to use. Now second method is to get the associated nodes for a particular given node. So get all associated nodes, def get nei neighbor. So we are going to get the neighbors. It will return a type, or it will be of type V. First input will be a graph. It will be of type graph. So this, let's import this. It will be from our topological graph, and next would be the node itself, which will be of type V. So this will return a sequence of V. This will be graph dot neighbors. Okay, spelling mistake. Graph dot neighbors, and it will be node. So now this graph is nothing but what we had implemented, a directed graph in our previous videos for topological sort. So you can refer this. I will provide link to this video in the description as well. So if you have missed it, you can revisit it. Now we have got all the neighbors. Next thing is, every time when we are going to append, we need to filter sequence from a sequence. So we will need a helper method. Sorry, we will first provide a description. Filter sequence from a sequence. So it will be def filter sequence, filter from a sequence. This makes more sense. It will be of type V. it will take the first parameter as sequence from. It will be sequence of v. Another parameter would be the, or let's keep it in the same format. First we will add the sequence to. That will be sequence of v. Okay, so now we don't need this. It will return a sequence of v. Yeah, so this will be, now it will be something similar that we had seen earlier, but here the difference is that we are not going to append to our sequence here, rather we are going to create a new sequence. So how we are going to do it? Sequence 2 dot fold left. Here we are going to pass an empty sequence. Okay, and here we are going to use a method sequence comma v. Now if sequence contains v, then it is going to be sequence. It's going to be sequence from, because we are trying to match the values which are not present. If else, it will be sequence v. So this is going to return us a new sequence, which will, this sequence will have values. So it will have all the values that are not present in sequence from sequence 2. Okay, now let's implement our depth first search. We have all the elements that we required, so it will be breadth first search. So now def breadth first search, it will be of type v. What it will require is a starting node. Starting node, here we will use a sequence. In a moment we will understand why we are using sequence here. And we need a graph of type v and visited. It will be again a sequence of type v, and it is going to return a sequence of type v. Okay, so now first thing is we need to initialize what are the neighbors. We need to understand what all neighbors do we have. Let's do proper indentation. We had created get neighbors method. Get neighbors graph is always going to be same, so we will provide the graph and we will have this as an empty value. Now every time we have this new start, we will get the neighbor out of it. The next thing is where next visited. So what we are going to have every time it visited is, we will add sequence to sequence. Here we will provide the first value as visited and second value as start. So every time we have the start, it will be appended to our visited, and every time it will check whether the values are present or not. If it is present, it will not append. If not, it will append. Now let's get the next item here. So what will be the next? So next will be the neighbors. So it will be so we have this, we need to understand that do we have any corresponding values available. So get next, and we are going to pass in all the values here. So now, so this next will hold all the corresponding neighbors, and it will get empty sequence if there are no neighbors. So if we hit the last node, then definitely there is no neighbor. So what we are going to check, we will check on next. If next dot is empty, if next is empty, then we are going to return new visited. Okay, let's mark it new visited, not next visited. New visited. So now it will be new visited. Else, what we are going to do with else? We are going to create new visited again, one, which will have what we are going to do is we are going to add all the new visited that we calculated earlier. So it means we have some value in our next, we will append it here. So every time on every level we are going to append all the neighbors in one shot. In depth first search we were going one by one, but here we will be doing on a level of sequence all the neighbors to be appended every time. So now we will be iterating it, and how we are going to pass in here is we are going to filter next, and here it will be visited. So anything that we have in visited will not be appended again. It will be, so the value here will be something from next which is not available in visited. So we'll be always we will be traversing on the nodes which are left or which are the neighbors, not the parent node. Next would be the graph itself, and third would be our new visited one. So this completes the implementation of breadth-first search. Let's test it. Where graph is equal to graph of v, that is, sorry, this is string, and we mark it like this, and then we will add edges to it. So let's add edges. First we are going to add a to b, then we are going to add edges that will be b to c, then add edges c to e. So you can add edges as and when you like. The order is will not matter, but the direction do, because this is a directed graph. So you cannot miss on any direction, or else you will have a different set of traversal. A to G. What was it? A to G. Yes. A to G. Then add edges. Then this will be G to H. Then add edges. This will be H to F. Dot add edges. Then we will have F to A. Add edges, and we will have D to E. So now we have this graph ready. Let's print our, so here we can initialize it as sequence of v, which will be empty because initially it's going to be empty. So let's print our best first search. Let's see how it returns, and we will start with our starting node, that is going to be sequence of a, and this is going to be graph. So why we are using sequences, we are iterating every time we are appending this value. So this can be improvised, you can use it as you like, but again the structure is going to be same, more or less it will be same. So here we have A, G, B, H, C, F, E. I think we have missed one node. Okay, we have missed here C to D. See, if we miss something, we are going to lose that information. Now we run it again. See, now A, G, B, H, C, F, D, E. Let's go back and see. It's A, G, B, H, C, F, D, E. And this is how it's going to be: A, G, B, H, C, then F, then D and E. Okay, perfect. If you enjoyed this video, please like and subscribe, and do not forget to click on bell icon for any future updates. Thank you.